Okay, let's try this question. Now, just let's focus up on here before we look at all the proof. There's more than one way to do these things sometimes, but first thing you got to do is read everything really carefully. You've got LOM as a diameter, so that right away makes that T3 there be 90 degrees. TN is a tangent, that's a tangent, so it does all the things with the tan chord thing, you know, here. And it says that ln is perpendicular to MP. That means N1 plus N2 is 90 degrees. Okay, well that's a lot of stuff. LT is a chord produced to P. LT, this goes straight through to P. And we're supposed to prove that this M, N, P, T, I travel around there and take a look at that quadrilateral. I want to prove that it's a cyclic quadrilateral. Well, look here, we've got some things here. First off, we've got this T3 is 90 degrees, and we've got this is 90 degrees. But if this is a quadrilateral, that's the exterior angle. The first one kind of just jumps out at you, and let's just take a look at it. They say that N1 plus N2 is 90 degrees because that was given. But T3 is 90 degrees because of angles in a semicircle. Well then, that means that T3 must equal this LNP angle, right? Yes, it must equal that. And therefore, this must be a cyclic quad. Why? The converse of the exterior angle of a cyclic quad. That's how I'd write it. The exterior angle is equal to the interior opposite angle. That's why it's true. The converse of the exterior angle of a cyclic quad. Or I guess you can write it just like this too. That's why it's true. Now the next question, let's see what they're asking us to prove. That NP equals NT. Well, that would mean these two angles have to be equal somehow. Well, this angle here, P, has to equal this angle here, M1. But then M1's connected here because that's a tangent, the angle between a tangent and a chord. And this T1, how is it connected? Vertically opposite angles. Now I might write in some of these things. You know, I know this equals this because of vertically opposite. This equals this because of the tan chord theorem. This equals this. And now I've done it. Those two angles are equal. But I have to write it out. Look how they write it out. T1 equals T4, vertically opposite angles. T4 equals M1, tan chord theorem. And then M1 equals P, the exterior angle of a cyclic quad. Well, therefore, this T1 is equal to P. That's right, because they're both equal. Yeah, they have to be equal to each other. Just looking at the relationship here, because T4 is equal to both of these things, so that means that M1 has to be equal to angle P. That's right. So, whoops. And if these two angles are equal, sides opposite equal angles mean that these sides have to be equal. And there's the proof all done. Example 2 done. There's some thinking in there, but there you go.